Hey guys, in this video we're going to be talking about independent probability and then dependent probability. We talked about this a little bit in the last video on combinations and permutations, but I wanted to go into it a little bit more specifically in this video. So independent probability is what it sounds like. It's the probability of two unrelated things happening. So if you flip a coin and roll a six-sided dice, what is the probability that you will flip a heads and roll a two? If you flip a coin and roll a dice, right, these two things are completely independent. They don't affect each other. Even if I rolled two dice, right, those would be independent because it's two separate rolls. They're not affecting each other. I could roll the same dice twice, and those would be independent because the second roll does not depend on what I got the first roll. So these are independent. So to find the probability, I need to just find the probability of each one separately and then multiply them together. So the probability that I roll a 2, well, there are 6 possible outcomes, and 2 is only one of those outcomes, so that would be 1 in 6. You multiply that by the probability of flipping heads. Well, coins only have 2 options, right? Heads or tails. So heads would be one option out of 2. And so this would be probability of rolling a 2 and probability of flipping a heads. And that would be a 1 in 12 probability. So that would be my answer, would be 1 in 12. So basically, independent probability is probability where they don't rely on each other. The outcome of the first one is not going to affect the outcome of the second one. All right, so let's look at then dependent probability. Okay, so dependent probability. So I have a goblet. It contains 3 red balls, 2 green balls, and 6 blue balls. So, right, dependent probability, if independent probability means that the events didn't affect one another, then dependent probability is going to be events that do affect one another. So we'll look at that here. If we choose a ball, then another ball without putting the first one back in the goblet, what is the probability that the first ball will be red and the second ball will be blue? So the fact that we're not putting the other ball back in is what makes this dependent. So in my first one, I have 3 red balls, 2 green balls, and 6 blue balls. But if I get a red ball first and I don't put it back in, then the second time I'm pulling, I only have 2 red balls, 2 green balls, and 6 blue balls because I've already taken out one of those red balls. That's what makes this dependent, is that I've changed it for the second one, right? Something has changed between the first and second. That's what makes this dependent. So in my first time picking, I have 3 plus 2 is 5 plus 6 is 11. I have 11 balls, so that's going to be my denominator. And there are 3 red balls. So there's 3 chances of getting a red ball. 3 ways I could get a red ball. So my probability of getting a red ball is 3 out of 11. My probability of getting a blue ball on my second pick. So on my second pick, one of the balls is gone. So the denominator has changed. There are now only 10 balls in the goblet. Okay. 6 of them are blue. 6 of them are blue, so there's 6 possible ways that I could get blue balls. Just as an aside, if I wanted both of them to be blue, for example, then the first one would be 6 out of 11, and the second one would be 5 out of 11 because one of the blue balls would already be gone. Or in this case, if I wanted both of them to be red, right, I would have 3 out of 11 and then 2 out of 10. But since I'm wanting different colors, that's not what's happening here because I didn't take out a blue ball. So I still have all 6 blue balls. I have only 2 red balls in this situation, but that doesn't matter. It just matters that the total has gone down. Hopefully that made sense. Okay, so I'm just going to multiply these together, and that will give me my answer. So 6 times 3 is 18, and 10 times 11 is 110. So I can simplify that, or I can just stick it in a calculator. 18 divided by 110. It's a repeating number, so I'm definitely going to put that in as a fraction. So that's going to be 9 out of 55, I think, is the simplest we can go there. I don't know if Khan Academy will care. Sometimes they care about things being as simplified as possible. So it's probably a good idea. But there we go. So 9 out of 55 is my probability. That would be about 16.4% chance of this happening, which is not great odds. Anyway, that's dependent probability. Something is changing from one to the other. Let me know if you have any questions, and I will see you in the next video.